Welcome to the third lecture in IoT. So today we're going to talk about research activities, IoT research activities. Last lecture we spoke about, we introduced you to IoT. Today we're going to talk a little bit about research activities. And as I told you, it's a very, very wide area, right? IoT is a wide area. So somebody will look at IoT as like a communications field, discipline. It's a communication discipline. Somebody will look at it as a wireless discipline. It's a wireless communication discipline. Somebody will look at it as mobile discipline. It is. Somebody look at it from security and privacy. It is a security discipline. From embedded systems, yes, it's embedded systems because you're going to have sensors, you're going to have devices to collect the data. Data mining, yes, it's a data mining. Why? Because we are collecting a lot of data. Cloud computing, yes, it's a cloud computing because all this data we collect, where are we going to save it? To the clouds, all right? Artificial intelligence, machine learning, deep learning, all applies, all of the above. So it's not like one direction. I told you, I want to keep repeating that it's very important before you go to a project or apply for a job, etc., that to see what the market needs. Okay, so for that you don't have to make phone calls. Okay, nowadays all you have to do Google. You have to do some search on the internet and try to find what are the trends, and you can find all of that. Okay, I truly encourage you to do that now, not 2 years when you start looking for a job. Okay, maybe we'll give you ideas which direction you have to go. Remember, most of you are doing masters, I think, right? Master degree. So you're gonna do like 11 courses. One of them a project is gone. You have 10. 5 courses is gone. You have to take them 5. There is 5. So a 5 could make you, this 5 collectives could make you the smartest person in one direction, in one area, in one discipline. All right? You could, in each one of the 5 classes, build a project. You could publish papers in each one of them. And you could have a fat resume ready for applications for jobs. All right? All right, so it's very important to know what you want to do. So if you, for example, a person would like to work in IoT, so a course like network security is useful. Wireless communications is useful. Wireless sensor network is useful. Mobile communications is useful. Algorithms is useful. There are some courses will make you an A candidate for area. If you are a person who would like to work, for example, in machine learning, right, or deep learning, so image processing is useful. Power processing course is useful. Deep learning is useful. DSP is useful. Python, because a lot of courses are done with Python. You understand? Makes you focus in one area that you could. You cannot know everything. It's very wrong nowadays. 20 years ago, it's good that you know a little about everything because there is a lot of jobs that you could really get hired and get trained in the jobs. Nowadays, they are looking for people who know right away from the day one, you have a job, go. You are part of a project, go do the project, right? So it's very important to think this way. You have strategic planning for yourself. It's a very important thing, all right? So myself, at the end of this class, at the middle sometime, I will tell you about my field in security, cybersecurity, IoT, this area, which classes that could help you to improve, right? Okay, it's very important to know this, and you choose. Somebody we fight our feelings. I mean, I like this area, but this area, it will get me job faster, okay? Or nicer, or bigger, or fatter salary, and all of that. Sometimes you have to balance. You are all smart kids, you look smart, and I think you know what you are doing. So, anyways, so we spoke about why the Internet of Things is a game changer. As I told you, the most important thing I like the most, it's a technology integrator. We spoke about it in the last lecture a lot. I need to get my pointer if I can. All right. So, all right. So we said it's a technology integrator, and I just mentioned like 5 or 6 fields that you're gonna work. This is a general example for connected network, okay? And we'll continue. I mean, we'll talk about this in details, every single item as we go and as we run. All right. This morning or the last class, we mentioned that it's all about what? About data. It's all about data. So we try to do data collection, and from data collection we transfer the data somewhere. Then we manipulate the data. We process the data. Then we try to get information from the data to apply, to take an action. Okay. And we said this data could be for analysis only, for further actions, or it could be for real-time applications. All right, repeated information is all about data, collecting the data, processing the data. We have to display the data in a format that we could read and you could learn from. We have to use the data either for real-time applications or for analysis. And then when we are done with the data, we don't delete it. We have to archive it in the cloud or somewhere that we could use it always. And then many operations we have to maintain, we have to provide maintenance, we have to provide support, logistics, fulfillment, etc., etc., etc. Right? There is many technologies involved. So today, the title of this class, if you remember, is about research activities related to what? To IoT. And this is one branch, one leg of the work you're gonna do in here, research. The bundle is already posted. We'll talk about it later. Okay, so when we think about IoT, okay, so any work, if you can, for example, work in a wireless LANs or LANs, okay, to work better for IoT, then that's a research work. Okay, networking, antenna, and this the last class we mentioned that the devices will have antenna to be able to send and receive data to connect to RF communication system. All right, so we need a new kind of antennas, maybe smaller antennas, maybe smarter antennas, okay, MIMO antennas. All of these we need them, right? So this is kind of research. So you could be part of a company that produce antennas. There's a section IoT antennas for IoT, for small devices, all right, for certain criteria, all right. So that's another research area, all right. So I mean, when you look about these line items in here, you could look at it as things that you need to adopt in your project. If you are like a part of a company that building IoT solution, you have to address all of these issues. It's from practical point of view. So you have to go to the market and see what kind of antennas they have to implement in my device, right? That's one. Or if you are a researcher, if you are R&D, research and development person, doing research, still all of these lines need to be improved. You need to have specific solutions, improvised solutions for IoT. So it depends what job you got. If you got in R&D, you'll be doing research. And you got in a company that produce parts and IoT solutions, so you'll be integrator. You'll integrate these already technologies. You have to understand how they work and how you can integrate them in the system, right? So you have to start somewhere. You have to understand. When it comes to the hardware, of course, I mean, like at the bottom, I mean, in my opinion, you could divide the parts of the IoT solution is in the bottom in here. You call it, for example, the embedded system, right? The sensors, for example, embedded systems, okay, microcontrollers, okay, okay. Then where you collect the data. So a lot of research work there. I need to design a sensor to do so and so function in so environment to collect so kind of data. Not all the services are available. So this is a lot of areas, right? Then you're gonna move this to the second layer, which is the communication. So the current infrastructure we have might not be enough to add trillions of devices to it. Might not be enough, okay, or billions of devices, all right? So we have to change the whole infrastructure, improve it, add to it, whatever it is, a lot of research, okay? Compress the data, deal with the data in a different way, I don't know, many things. Then on top of that, what you have, so including in here, then the servers. So think about cloud computing to save the data. Think about the servers manipulating the data. Think about the servers that processing the data. Think about the servers that sending back actuators, actuating actions, taking actions. All right. So all three levels, okay, are prone for research and improvement. All right. So we spoke about this, the components, and we're going to talk about this structure, the architecture of M2M or Internet of Things design in much details as we go. All right. We spoke this morning about some of the protocols, protocol stack, and the differences. And by the way, why we don't use, why we use, for example, DLT in M2M or in our thing? Because TLS is too complex, it's too heavy. So we have to come with a solution. That is a result of research work. Why we have to 6 low band, okay, instead of the normal protocols like TCP or whatever, or IP4 or IP6. Why? Because again, they have problems and the size and the power consumption and all of that. Okay, and then why you have to use RIPL instead of like other routing protocols? Because the standard routing protocols might not work for many applications. Okay, we gotta come to standardization at a certain point. I hope soon. Okay, and we have to look at the functional elements of any M2M. So you have field of domain, okay, and you have infrastructure domain. How they interact, we're gonna look at these boxes in details as we go in the class. And here I'm gonna just focus in the research areas. I'm giving you a general idea, then we're gonna focus on the research area. So, for example, if you look at surface elements, so you get there is application entity. As I told you, it starts from underlying network, surface entity, okay, NSE. On top of it, what we have, common surface entity. On top of that, we have the application entity. So when you look at the underlying network surface entity, you talk about anything related to networks, communications, wireless, cellular, etc., etc., etc. Okay. In the surface entity, what are the functions, for example, you're gonna need for any system? Remember, you're talking about a wireless system. Didn't you think, for example, that you're gonna have application and surface layer management for that? You have to have communication management and delivery handling, data how to be handled. Okay, data management and repository. Where is the data managed? Where is it stored? How to be read back? Device management. You need to manage the device. You know, sometimes you have a problem with your iPhone. It's a device. It's kind of IoT, right? So, I mean, you allow people to the company to get to it. They try to ping it and try to, you know, change some configuration for you remotely, right? So you're gonna have discovery. So when you move with your wireless device, you're gonna move from one network to one network. So you have to discover what is the current network happening now, and the network has to discover you are existing, right? Discovery, how these protocols has to work. Group management, how you group, you know, certain devices together. Localization is a big issue. Localization, right? Think about a medical device that you have, and you're gonna move with you wherever you go. So what will happen when it moves from area to it has to find you. To find where is your localization. Are you using GPS or using different technique to do the localization, right? network surface, exposure surface, etc., etc. Registration, okay? Like for example, GSM, right? That's a good example. GSM. So GSM, if you are in this country, it's registered with T-Mobile and all of that, right? You move to India, Hyderabad there, so it cannot communicate with the bridge here with T-Mobile. It gets itself registered in the local network there, okay? And the local network register you with the mother network or mother, registry, right? Registration. So you have to register, the device has to register itself, okay? It will, whenever you're trying to dial a number, it tries to get it from the local registry, the dictionary, not from the remote dictionary or remote, numbers, for example. Security. Don't you think security is a major issue? It's a major issue. However, first of all, do you think that we have secure networks now? No.
Never.
The cyber theft in billions, if not $1 trillion every year. Yeah, there's a credit card thefts, there's, all cyber thefts, identity thefts, okay? It's worth millions or trillions of dollars every year. There is no secure network. By the way, you could have in your bank account like $1 million, next day you have zero. Somebody managed to get your identity, managed to get in all of that, right? You have a very safe, you think you have very safe access to your Google and your information on all. Myself, I have a Google Drive. I save everything in my Google Drive, right? If somebody breaks in, okay, he will see he will know everything about my life, okay? Just I want to check the pictures again. I hope I don't have like a picture I'm not, taking care of myself. And everything will be there, so be careful. So the right assumption that whatever you store in the cloud, it's not secure. Okay, it's not secure. All right. So make sure things that you don't want anybody to see it. Don't keep it in the cloud. Okay, just that's the right assumption to do. Right? Okay. All right. So security is a big issue. Then surface charging and accounting. You sell a product, okay, is it one-time charge? Is it monthly charge? It could be monthly charge. Is it annual charge? How is it? So all of this has to be implemented, right? You talk about subscription and notification. So all of this part of the common service entities. Then the application entity, this is unlimited. You could think about 1,000 applications. If I give you a paper and pencil until you think about applications that you need to use for IoT, you might come with thousands of ideas, right? All right, so that's unlimited. All right, so system level features that Internet of Things needs to support. We spoke about this morning, device heterogeneity. So devices are not homogeneous, they are heterogeneous. So you should be able to connect your device to a laptop, to a network, different kind of network, in a wireless environment, in ad hoc environment, in different real environment, so heterogeneous. The second thing is scalability, scalable. So when you create a system, a protocol, you could create like a routing protocol, which is good, for example, for 1,000 devices connected together. But what if you scale it out? Does it work for 1 million devices? 100 million devices? So whatever you try to bring there, it has to be scalable. Scalability is a very important issue in research. So for example, naming and addressing. So when they created, this is a good example. When they created IP version 4, all right, what is the size of IP4? 32 bits, right? So theoretically, what is the maximum number of IPs could have? Theoretically, it's much more less than 2 to 32. Almost gone. So when they created this 30 or 40 years ago, it was a lot of IP addresses. Whenever you consume these IP addresses. Now we don't have, it's gone, right? That's why we come with IP6, which we're going to talk about in here, 128, right? 128, right? So IP4, 40 years ago, when you looked at it, it's scalable. It is scalable now. it's gone, right? Okay, and you know, many issues. Another thing about this, when you think about it, 40 years ago, most of the data we sent was what?
Text.
Simple
Text
text.
in a document.
Nowadays,
Yeah,
I mean, like the maximum, I mean, a file is like 200K, is huge at that time. Now one image is like how much?
30 MB.
Five, right?
From an iPhone, it's more than MB, 30 MB or something. 40.
Exactly. So what is the scalability, right? So you have to think about the future is, okay, data communication and networking. That's good. Again, we still talk about scalability, information and knowledge management, service provisioning and management. Then, ubiquitous data exchange through proximity wireless technologies. So, how the data will exchange? The spectrum availability. You know that how you know the bandwidth is like bought from the government. You cannot go and use any bandwidth you want, right? So AT&T or T-Mobile or these or the Army, they get bandwidth, certain bandwidth. If you send data through bandwidth which is not assigned to you, you know what will happen to you? You go to jail. Okay? You go to jail, right? So that's a major thing. But we don't have a lot of spectrum. Right? Or the spectrum that we could have hardware to support is limited. Right? So what we're gonna do with all of this communication? The current spectrum where the hardware can support is not enough. So we have to find different techniques. So if you took DCC, what we do, encoding, right? Encoding. So we're gonna have different techniques of encoding. So we could encode, right now we could encode that data with that much hertz. But if we can encode that much data, big data, with the same kind of hertz, that means it's much more efficient usage for the spectrum, right? So a lot of research needs to be done. So that's we talk about cognitive and dynamic radio systems. So you don't design a device that only use this bandwidth. If it's available, it can work. If it's not available, it cannot work. No, it could be cognitive, it's dynamic. Changes and all of that. So what kind of, a lot of research, a lot of work there. Then, energy optimized solutions. The major, these devices run out of batteries. So if you work in wireless sensor network, the idea of wireless sensor network, I mean any definition, you read any definition for wireless sensor network, you know what they tell you? It's unattended devices. That means you throw them somewhere, you never give them back. So you expect them to work for 2 years or 3 years to collect the data, do the function, okay? So you need to have a minimum power consumption. You have to conserve in the power. How you can conserve in the power? You have to design different kind of batteries. Long life term batteries. You have to reduce the amount of data you transmit. Every bit you send extra, it will cost you more energy. All right? Routing, okay, security, what's security? Encryption. You know what's encryption? The data is like that, it becomes like that, because you can add many other devices, for many other components for the packet, and it becomes bigger. So the harder, the better encryption, the regular encryption, that means the data is like that. This is my message, I love a bridge book, it becomes like that. And because it moved from that size to that size, then the power consumption moved from here to there. You have to create techniques that it does not wake up all the time. It's sleeping and wakes up when it's needed. Because when it's awake, what will happen? It will consume power. I'm just giving you, I'm naming some small common things to you. I mean, can you come up with many other solutions? You could, okay, you could. The idea here in research that you are creating a hypothesis. So you say, if we create the algorithm or this protocol, it work in this way, okay, and will consume, it will conserve in the power, okay. All you're saying now is hypothesis. That's your hypothesis. I think so. Hypothesis. Hypothesis is not enough. So you have to test your hypothesis and make sure it's working. If it's working, okay, you have to show how you made it work, how you can convince people to work, and you could sell it, you could publish it, you could share it with the whole world. That's what is research about. Research about coming with a small idea. I mean, research is not anymore like you think invention. Research is not invention. You are not expected to invent the light bulb again. You are not expected to invent the car again. It's already invented. What you are expected from the research, from the millions of research projects are happening in this field, you gotta take one part, small part, and do some improvement to it. And you compare your work with the previous work, and you put it in the paper and publish it. When you publish it, who's gonna read it? The scientists around you. The scientists from there, they take it, and that's how it is. That's how the whole world right now sharing with the knowledge. It's not anymore United States that produce the technology, or China, or India, or Pakistan, or whatever, Philippines, or Saudi Arabia, or whatever it is, you know, Brazil, or Europe. It's the whole world. It's the whole world. So that's what is research. Research is to contribute even a little to the field and publish it and share it with everybody. Then, so localization and tracking capabilities. So we need to know the location and remove it in most of the applications. All right. Then self-organization capabilities. That's a very important thing. So you could have, for example, these computers in here. Okay. They are not self-organized. They are organized and hooked to a network because they are static. They are not moving, right? All right. So this computer is connected statically to where? To your network. It has okay. But if your device, let's say it's a mobile device. This machine now gonna move to California. If I plug it in, we'll be able to hook to the internet. Right? So self-organizing networks. Network builds itself by itself. It's based on the situation, in the location, in other information. All right? Self-organizing network. Okay? So distributing intelligence, smart objects, autonomous organization, the transient ad hoc networks, sharing data for performing coordinated tasks. Coordinated tasks, right? Device and surface discovery, building overlays and to do adaptively tune protocols, behavior, etc., etc. So these are all part of self-organization capabilities. Okay. Then we have semantic interoperability and data management. So we have to exchange and analyze massive amounts of data. Also, we have to think about the interoperability among different applications. Support for automated reasoning. You collect the data, you don't need a person to analyze the data by eyes. It has to be automatic. Remember, you're talking about a huge amount of data, okay, and a huge amount of decisions, okay? So you have to automate that also. What kind of actions and all of that. After that, embedded security and the privacy preserving mechanism. We spoke a lot about the privacy and security should be considered a key system level property. There is no IoT solution will fly without a good security system. Okay, and privacy. So also there is many terms. Who took network security before? 1, 2, 3, only 3. Nobody else. Okay, so you know when we talk about network security, there is a lot of terms. People from outside the field mix them. So authorization is not authentication. Privacy is not necessarily security. Okay, and so on and so forth, right? And privacy, it is a wide word. I mean, for my mom and your mom, probably privacy is a privacy, right? But when you talk scientifically, privacy it's a huge thing. So for example, there is something called location privacy. Location privacy, okay? I'll give you example. I mean, this becomes like, you know, very, very, you know, scientific terms that, you know. So for example, okay, let's take an application for wireless sensor network, right? So let's take an application of animal protection, like pandas. You know, there is limited number of pandas, so we decided to keep them in the habitats where they should live, and we have sensors, right? Why the sensors are there? Why we need the sensors? Okay, sensors when there is a panda here, panda, you know the panda, that any animal you like, monkey, if you don't have enough monkeys in the world, panda, this is a panda. Okay, if it's in here, it has the sink, there is a sink, okay, that collects the data. All right, so because these are wireless sensors, they have limited range, usually have limited range, so this one is close, because it's directly, right? But this is too far, it has to send to here, to here, to here, right? So we have to think about routing, how routing is done and all of that. All right, so if this sensor, sensor 1 for example, discovers a panda, can I send information to the sink that we have a panda nearby, right? Is that good or bad? Good. Good or bad?
Please can you repeat it?
Huh?
Please can you repeat it?
This sensor discovered a panda, send the data to the sink that a panda is here. Is that good or bad?
Bad.
Bad. Why is bad?
Because the other pandas can
Somebody
know about
taps to
the
the that frequency.
current
One
panda.
person. What?
The other pandas can know about the current pandas. Same.
The other pandas they cannot read computers. You know the pandas does not read computers. We are here to protect them. So there is another panda in here. Panda 2 in here. Discovered. Send a message to the. Is that bad or good? Yes.
I think it's take for a long time to retrieve the data.
Let's say it's a very fast time. That's fine. I mean, here we're just reporting. There's no real-time action. You just to know where is the pandas. Are they safe? Are they good?
But it will be have maybe multiple time for same data, because maybe you have data in point A and another panda in point B.
Sure.
And that time the data send it. That
Sure,
mean-
but we will send this message in here. This sensor will say, I have a panda 2, okay, next to me, right?
Yeah.
All right. So let's say panda 1 here. So sensor 1 will send panda 1 is next to me. Sensor 2 will say, sensor 1 send me a message that panda 1 next to it. Sensor 3 says, sensor 2 send me a message came from sensor 1 says send panda 1 into sensor 1. Okay. And the sync now, what does the sync know? That he received the message that sensor 3 had a message from sensor 2 telling that sensor 1 has a panda 1. There's no problem with that. I mean, let's say we have 200 pandas. I mean, they could communicate, everything would be stored in the sync. Right? What's the problem? There's a problem?
Can it be improved? Can it be like on event based? There is an event based, so all the nodes will, there will be one node generated, and that will elect as a master node, and then they will send it to the slave node. So that way the power efficiency can be more improved.
So you're talking about power, improving the power. Okay, that's a. But in terms of privacy, I'm talking about privacy. What's the problem with the privacy here?
Other nodes are getting the information, right? Is that the
That's
problem?
fine. The nodes are part of us.
So it's easy to hack. Yeah. From
So
you can hack any
cryptocurrency.
point and you all information.
Sure. Let's say, okay, let's say that all the data is secure. So the data goes from here to here to here to here, all encrypted. So even if they hack it, if they get the information, they cannot read it because it's encrypted. What's the problem?
It's just telling one information that panda is there. If they even tap to the frequency, they get the data. And that means that panda is somewhere there.
Exactly. That's very
They
clever,
don't
very
have to
smart.
be-
So the fact there is there is a thief in here trying to kill the panda, right? In here, right? So he does not need to read the data even. So when he sees a transmission happening from he has a device, there is a transmission starting in here. What does it mean?
It's a panda.
And
Panda is there. He does not need even to read the data. He does not need to know. Just the fact there is a transmission, what he will do? Go get the Panda. So what we call this a problem? Source, location, privacy. Maybe you can read 200 papers about this issue, how to solve this problem. So in here, they're not looking, it's a privacy. About that, yes.
I remember I read some situation about the smart refrigeration. Today in the morning we're talking about
Sure.
this situation, because they will track so many refrigerator in the neighborhood,
Sure.
and they will catch who's one in hold doesn't
Sure.
request any food
Sure.
and go to steal that
Sure.
house.
Sure. So it's just privacy.
Privacy.
Privacy. It's a big issue. I mean, you could have the best encryption technique, and you haven't. But still, the fact that just there's a transmission. Of course, there's many solutions. I told you like 200, 300 papers just suggesting solutions for this problem. I could share one survey with you about it, right? Okay. So this is one problem, a small problem. It's a big research. You could spend a whole year just providing a solution. And you are providing a solution, many other people are providing what? A destruction for a solution.
Yeah.
Right? So that's how it is. Alright? Anyways, I have to go faster. So 3 main system level characteristics of IoT. So we're talking about system level characteristics. System level characteristics. Number 1, anything communicates. So smart things have the ability to wirelessly communicate among themselves and from ad hoc networks of interconnected objects. Anything has to communicate. Okay, anything communicates. Number 2, anything is identified. Anything has a unique. So this computer, is it identified? Yes. By what? By IP address. Unique IP address. So any device in the whole world has to have a unique IP. Okay, so it has to be uniquely identified. I'm driving the cameraman crazy. Keep going left and right. So. All right, but also I'm keeping him awake. So it's good. So smart things are identified with a digital name. Relationship among things can be specified in a digital domain whenever physical interconnection cannot be established. Then anything interacts. So smart things can interact with the local environment through sensing and actuating capabilities. So sensing or actuating. You sense. You send it to the server, then actuate something. You sense it's cold in your room. You send it to the main server, the action will be turn on what? Heater. Heater. Okay, sensing, processing, and actuation. All right? All right. So research challenges. So embedding computing and communication capabilities into objects of common use. So embedding computing and communication capabilities into objects of common use. Identification. So how can you do identification? Unique identifier, identified, or a class identifier. RFIDs, you know the RFIDs? Yeah. By the way, that will be your research topic. I told you this morning, RFID with authentication. So I chose for this class RFIDs. We're gonna work on RFIDs, and we're gonna work in authentication, okay, authentication. So we'll create the bundles for you that we're gonna read, and we're gonna come with smart ideas. So there is RFIDs everywhere, right? RFIDs can be passive or active, right?
Yes.
Okay, all right. So is there a security issue?
Of
No
course,
security issue. Think about, for example, like you buy a jacket, right? I mean, a jacket, right? Expensive jacket. What does it have? In the morning, RFID. Okay, so this RFID authenticates, right, to the server. What if somebody attack it that deactivate it, for example? Right? Press it and deactivate it, right? Deactivate the authentication. Or through the RFID also sometimes, you know, the price, right? It's not only for security, the price. What if you attack the RFID and the jacket, for example, like $2,000, you may hit at $200. All right? So we're gonna talk about, you know, that's what we'll be doing this class, okay? Identification, then sensing, actuation. So it could be passive, performing sensing operations, passive. In passive, that means passive, right? or active, performing actions. Interface and coupling between the digital and the physical realms. How is the interfacing is happening? Okay. Also, sensor actor network. Okay, we call it SANETs. So sensor actuation network. Okay. So you have the sensing in one place in the whole world. You're gonna go. You have the actuation, or maybe they could be in the same place, right? Okay. So how you can create all of this, right? Classification of research challenges. So first one is computing, communication, identification technologies. Wide area, right? Computing, okay, communication, identification, then distributed system technology. Many systems that we have distributed. It's not like, okay, and distributed intelligence. So you could handle. So for example, that you need to monitor, for example, the whales all over the world in the 7 oceans and all the seas and all of that. So that has to be distributed effort, right? There is networks, IoT implemented in every ocean, connected maybe to satellites. So it has to be distributed intelligence, distributed effort, distributed network, somehow to be handled, right? All right. So when you look, so let's take a look at the 3 of these. So the first one is computing, communication, and identification technologies. So in computing, communication, and identification technologies, let's just go through it very quickly. By the way, I know by now, after the 2 or 3 lectures we had, that you know a lot of things that worth research, right? In here, trying to just generalize things, right? So embed computing, communication, and identification capabilities into every object. So every object, it will be able to communicate, it will be able to do computing and processing, and it is identifiable. How can we do that? Then number 2, low cost, low power communication, micro, nano electronics. So you have to use even the level of the chips and the technology and the microcontroller devices. They have to consume very low power. Number 3, advancement in near field communication, RFID like, for identification purposes. So you have to advance the near field communication. Then the protocols to perform active sleep duty cycles. Why active sleep? Because you don't want the device to be awake all the time consuming. So sleep, then wake up when you have to do some task. Make sense?
Yeah.
All right. Then distributing computation in order to reduce the communication overhead. Okay? Then, for example, in here, which one will die first, you think? This one or this?
The one near.
This one.
The one here.
Those here. Because this is only sensing and sending.
Then it will
Okay.
sleep. Yeah.
So will send everything this way. This one anything could come from it and send it, so it will be much more busy. So if I have a network like this, remember I said one of the problems that we have to handle is routing, networking. Okay? This device will die before this device. Remember what's our goal? To make the whole network live as long as possible. So what's the solution? Many solutions. Many. If you go to the literature, many solutions for that. Right? Localization systems. What kind of localization systems? Maybe we'll have like 2 lectures about localization systems at the end of this class. All right? Proximity detection schemes. Then distributed systems technology. So enabling objects to build a network, creating a distributed platform that enable the easy implementation of surface and top. So now when you're building a system, you don't have to create everything. So you could have off-shelf applications, off-shelf components, off-shelf, devices. They could integrate in your system, right? Off-shelf means it's ready. Just you have to implement surface and top. Okay, distributed system is defined as a system driven by separate components which may be executed either sequentially or in parallel. Sequentially or in parallel on different interconnected nodes. The distributed implementation of routing protocols. So routing protocol, what kind of, okay. Then issues concerning the impact of misbehaving nodes. You have a network, of thousands of nodes, some of them misbehaving. And here, for example, delivery of the data from here to here depends on the behavior of the one in here, right? Because there are relays. I mean, this cannot send directly. It has to send to another node. So if these start misbehaving, what will happen for the whole network? It will stop working. Any network, something could go bad, but everything depends on something else. Okay? So what you do with the misbehavior in the network? Okay, what kind of fault tolerance you have in the network? All of this you have to address. Okay, replace, repair, reprogram faulty, possibly embedded devices, synchronization of the clocks of tasks. Aha, this is a major thing. You have thousands of devices, they are by themselves. How they communicate? They have to be synchronized in time. Well, there is time drift. What will happen? They are not being able to communicate, right? So how can you synchronize the devices not connected together? Right? So this, for example, I'll give you an example. This is connected to the LDAP server, to the UB server, right? If there is time shift, it will not be able to connect. It will not be able to authenticate. Because part of the authentication package, if you did security, is the time signature. So it has to be different within a fraction of a second. That's why we have the timing server connected to timing server. Okay? If you change the time now, make it wrong. You try to connect to not. Maybe that's one of the reasons you're not able to log in. Maybe there is a time shift. It will not authenticate you. All right. Oh, synchronization of the clock task and middleware designs. You know the middlewares and all that between different technologies. Then you have distributed intelligence. Suitable interfaces for programming purposes. Applications need to coordinate communications and computing in order to leverage the data coming from several information sources. How autonomous software entities, usually referred to as agents installed, okay, to handle, okay, can be made able to interact with the environment and among themselves in such a way to effectively pursue a given global goal. Agents, how you install the agents in these computers, and okay. Then preserve computing, ambient intelligence application, and surface-oriented computing. Okay, scalable service delivery platform and multiple services to coexist. Right? So these are the three things that will repeat them. So in here we said classification of research. This is one of the classifications. It's not necessarily the best classification. I just picked one of the classifications, right? Okay, so security words could be part of the three, by the way. Okay, all right. So when you go in here, for example, taxonomy of research areas level in the Internet of Things. So distributed intelligence, distributed systems, common communication identification. When you talk about security, it spans three of these. Right? Security itself, right? When you talk about, for example, communication, computing, communication identification, like energy harvesting, low energy computing, all of these are areas of research that you could classify them in one of these areas. Security as an example, I mean that's security, just giving idea, I gave you about privacy. Some of us don't know what's privacy, right? Now we come to privacy. So privacy could be location privacy, could be rate of privacy. What is the rate of transmission? Okay, it could be different kinds of privacy. Privacy or security usually in generally divided to contextual and textual. So privacy of the text itself, or about things working with the text, called contextual. So for example, this is textual or contextual. The location is contextual. We're trying to keep the location private. But if I need to keep the data private, this textual private. So it's a very wide, and this will do it in network security, you know more. All right, so security, data confidentiality. Data has to be confident, okay? I don't want to go in details. Privacy, okay? We just gave privacy example in here, but it's wider than we think. Trust, So security policies regulating access to the resources and credentials that are required to satisfy such policies. So talking about policies. Okay. Security challenges in Internet of Things. So data confidentiality, privacy, trust, you could think about all on details. Wireless technology selection criteria. So what kind of wireless technology you're gonna use? You're gonna permit a device to do certain function, medical device, whatever. Okay, what kind of wireless technology you plan to use? Are you good? So you have to think about the data rate required. It doesn't require. So if this is taking video and sending a video, so you have to use a wireless technology that has a higher bandwidth. But if it's taking a text, it could use a technology that use average data width, right? You have to know what's your application, what's your need. So what is the volume of data you expect? What is the latency? Remember we spoke about real-time applications this morning? Real-time applications. What is the latency that you allow? Could be late, the data, could it be late? Or it has to be in real time? Huh? So that will help you to choose the wireless technology. Then you talk about geographic reach. So carrier support, frequency bands, mobility of the solution. Is it mobile or not mobile? Okay. Costs, like hardware, connected charges, data charges, certification ease, regulations, carrier approval. So if you're going to use one of the bands, the free bands, right? That's easy. But if you're going to use, like, you're going to require a certification for a specific band, that means more time. That means more time. All right. You need a break, guys? Would you like to have a break or just continue half an hour and leave? Break? Break. Who wants to have a break? Only me? Okay, I will continue. All right. So, cellular frequency band issue. Why do you care? Is it cellular frequency? Why do you care about the frequency? Okay, so it affects the module vendors offering. So each band associated with one or more carriers. The carriers in T-Mobile is different than the others, right? So the design, if you're going to use T-Mobile, the chip you're going to design, it will be different than using for example, right? You agree? Right? GSM by itself, in India or different countries, different bands, right? Long time ago, the cell phone works in countries that don't work in other countries. Why is it working now? Not because they are the same bands, you know that. Because they designed the phone to work in 3 or 4 different bands. So it will choose one of them, right? But if you are buying a very cheap one, you might not have this thing, Does their offering cover enough of our target spectrum carrier? More flexibility, more dollar from you. If you need to have more flexibility, more dollar from you. Many of the countries, the people didn't use one carrier. They use use a phone that different GSM, 2 or 3 GSM, right?
Yeah.
Because when you call from one company to another company, it's very expensive. So in this country, you cannot even buy maybe like a cell phone that has 2 or 3 cards, right? SIM cards. But many other countries, you could have it, So, those phones would be more expensive than it has one SIM, right? So think about it this way. The more flexibility you have, the more money you're gonna pay. Inventory control issue. Then antenna technology affected. Is it external? Is it internal? What kind of performance that you need? Then desensitization from your digital circuits. More bands, more concerns. Non-cellular, this is for cellular technology. Non-cellular technology, there may be a gateway between the cellular network and the user side. Sensor networks and medical monitoring and all that. There's a lots of choices. Wi-Fi, MiFi, Bluetooth, LE, ZigBee, wireless, RFID. All of these are options for non-cellular, right? These are Wi-Fi. So in this class, we're going to work mostly in Wi-Fi, non-cellular. Maybe we'll try to do some cellular application. That would be good. Any application you're gonna use an iPhone, of course, you're gonna make it silver, right? Because that's how you communicate. Decision based on applications, so it's trade-off considerations, communication distance, data rate, power consumption, all of these. Example for non-cellular technologies: Wi-Fi, Bluetooth, Zigbee, mesh networks. Look at the rate. I mean, look in here. I mean, you know, for example, if you need to have like a higher rate, right? So this, for example, in here, for example, this is the 4G or the Wi-Fi. The Wi-Fi is a small rate, right? The 4G is higher rate. Zigbee is small rate. And then what's the spread of the bandwidth? Okay, so all of these issues you need to think about. There's a lot. Remember, this is what they call it off-shelf technologies that you need to take integrated in your system. So for that, it's not just you're gonna close your eye and pick. You have to have deep knowledge. You have to know how it works, how possible it will integrate with your work. Okay, you have to think how it will affect the environment, how it will be affected by an environment around you. How about noise level? How about the thousands of things that you have to worry about? Okay, you have to be very knowledgeable when you deal with these things. The hardwares, for example, okay, hardwares could be industrial, commercial, and consumer. Okay, so for example, what are the robustness? For industrial, it has to be very severe robust. It will be very robust, but it will be also very expensive. In commercial, benign, does not matter, but in home, for consumer, it's a moderate. All right. So you can talk about robustness, environmental, hardware precise sensitivity, antenna. Let's take a look at antenna, for example. So industry, if you need device in industrial room or something, whether it's internal or external, does it make a difference? It's a factory. Does it make a difference? Okay, in commercial, external. But when consumer, and if you give you a device like this, but the antenna is that big, external, does it work? No. Okay, it does not work. So you have to take a look at all of these. So for example, life in the field, so 10 to 20 years. But usually any device you buy at home 3 to 5 years, all right? And this also reflects in the price. If you offer a very robust device to sell at home, any device now for $2,000, how many people can buy a device for $2,000? You're a person have a diabetes, and they tell you that we have a device that could control your blood sugar, so it can pump insulin in your body according to sugar level. It's $2,000, and you have to pay for it. What are you gonna say? And I say, oh, well, I use meat. I don't see it. $2,000, it's a lot. All right, most of the people, right? Okay, all right. So that's the most important thing. Okay, anything. Sensors. There's so many kinds of sensors. So thousands of sensors that we could use. Okay, so many applications use sensors, sensor nets and gateways. Common times, location, something determine location, orientation, temperature, fluid levels, chemical detection, vibration, etc., etc., etc. Every sensor has a function to detect something. All right. So if you look about the sensors just to check temperatures, so there's maybe thousands of them. What are the levels? So the temperature of the volcano is different than temperature in your house, right? Right? Okay, RFID, passive or active. It could be passive and active. That's what you're gonna work on in this class, all right? Impacted subsystems, so power systems, cycling, and regulations. PCB layout for the return current and EMI. What is EMI? Electromagnetic interference. Electromagnetic interference. That's a big issue in many networks and all of that. Okay, so if you're creating a device that is going to work in a big factory where there's a lot of machines, so that means there's a lot of EMI, electromagnetic interference. But a device that you will use at home, you don't have a lot of electromagnetic device, right? Alright, so this is a big issue that you have to handle, right? Oh, we spoke about the power system, cycling and regulations, interference, and packaging. So packaging. So you could reduce the EMI by the kind of the packaging. So you need a beautiful packaging, or you need a working packaging with an application. Alright? Work side interface like his wired, USB, legacy serial system, some wireless, all of these options are available. Cellular modem implementation options. So these are different cellular. Some of them are hooked up to your computer with like USB. Some of them, with serial. Some of them, different ways. So for the practical implementation issues, enclosure considerations, RF antenna, error behavior, noise and interference, radio access technology, roaming. Oh, we did not talk about roaming. Roaming when you move. So let's say you have a device that's subscribed to a certain wireless network cellular system. So roaming, like your cell phone, when you move from place to place, you have to do roaming, right? There's an issue. Then what is the last one?
Testing.
Testing is a big issue. By the way, sometimes testing it takes a similar time of that implementation and design and building and all of that. Testing. Okay, like for in medical fields, when you come up with a drug, you spend like 10 years testing. Okay, it will be the same thing if your device is related to medical. It will take so many years. They will never put people's lives in danger. Okay, testing. So how is testing? Is it real testing? Is it testing on people and all of that? So in here I try to cover, just give you idea about the research, ideas that you can work with and deal with in here, right? So in this class you'll be doing a research about RFID and authentication. We have created 6 bundles, A, B, C, D. Each group, each group will work in lab, group of 2, in the research group of 4, right? So you could join 2 groups together, or I don't care, right? And it starts with reading the bundle, try to come up with the idea. You need to reverse engineer it. You have to sort it like that. Okay. So in this class, basically, it's all work. All work. I mean, all work. It's like work in research, work in that. After 2 weeks, 3 weeks, you will be presenting it. So everybody will be presenting in the class. Like you're gonna have a whole class to present your paper and your ideas and all of that. So in this class, luckily, I will not be the only teacher. Okay, you will be teaching me, teaching yourselves, teaching others in here, and it's like a 500 level class. We're expected you have this talent to do. I'm sure you will do very well. Okay, any questions for me?
Are we allowed to pick our own topics for research or only from
No,
content?
it's already picked up. You can pick 1 out of the 6. All right.
If you pick one topic, then
There is 6
how
bundles. You have to pick one of the bundles.
Yeah, but how will other people know that what this topic has been picked?
So everyone, for example, group 1, you don't have to continue this. Thank you so much.